Honors Algebra 2, Chapter 6, Section 1 and 2. So we're going to evaluate roots of real numbers using radical notation and exponent notation. So really what we're doing is looking at exponent notation we talked about in the past, and we're going to just apply radicals to that. So looking at this pattern, 4 cubed is 64, 4 squared is 16, 4 to the first is 4. Let's skip this one for a second. 4 to the 0 is 1. So looking at this pattern, 64 to 16 to 4 to 1, what's happening here? What would 4 to the 1/2 be? Kind of what would the process here? Well, we're dividing by 4 to get 16, dividing by 4 to get 4, dividing by 4 to get 1. So right in the middle of here would actually be 2 here. What would the value be? So what makes sense for this? What does the 1/2 mean? Let's try that again. 9 squared is 81, 9 to the first is 9, 9 to the 0 is 1. What is this value? What's 9 to the 1/2? And seeing this pattern, so actually the 1/2 here is actually like square rooting is what we're doing here, the square rooting of 3. So the square root of x is actually the same as x to the 1/2 power. So this is actually the main rule we're going to use for 6.1 and 6.2. And when we just combine that with all of our other exponents. B to the nth is a, so if we have the nth root of a, it's b, kind of the opposite. That's using just the definition of square roots. So we can also write those as rational exponents. So a to the mn can be written as the nth root of a to the mth, or the nth root of a all to the nth. Those are all the same, but we can rewrite this fractional exponent, so a rational exponent, as a radical form. And we can do something with a negative exponent here, so a to the negative m over n for this. Recall how to get rid of the negative exponent is put the whole thing in the denominator. So 1 over a to the m over n, which then would be the same as 1 over the nth root of a to the nth. And then we can start dealing with getting the radical out of the basement, out of the denominator, once we start having values. But this is where we're going with this. We're actually just taking this one rule of that a fractional exponent can be written in radical form. So this is exponent notation, and this is radical form. So this is written as an exponent right here, and this is written in radical form. The two forms for those roots. So real nth roots. If n is odd, then a has one real nth root. So for this question, if nth root of a equals 1, a to the nth root of a is the same thing as a to the 1 over n power. And if you look at a, if n is odd, so if we have like the third root of 8, the solution to that, this thing as a to the 8 to the 1/3 power, which is going to be 2, because 2 times 2 times 2 is 8. We get one solution from there. We do the same thing, the cube root of negative 125. Now this one's a little more interesting. For this one, it's actually going to be negative 5, because negative 5 times negative 5 times negative 5 is negative 125. And then if n is an even, there is usually 2 roots. So if we look at the n value being even, so the square root of 16, it's going to be plus or minus 4. And that's because a negative 4 times a negative 4 is still positive 16. And so this is really when you're looking at solving like x squared equals 16 and you square root both sides, then you get the two possible answers. And so if we have the fourth root of 16, the answer could be positive or negative 2. Now, if you're just given the actual fourth root of 16, the answer is 2, but really it'd be like x to the 4th power equals 16. To isolate x, you actually want to do the 4th root up to both sides. So x is plus or minus 2, because 2 times 2 times 2 times 2 is 16. So again, you get the plus or minus when you have an even root to both sides. If you need to do an odd root to both sides, you don't get the plus or minus. You get the single value, the one real root answer. And so here's some examples. If I have 16 to the 5/2 power, we can write that in radical form. So the denominator is our root, so this is really going to be a square root. 16 is what we're taking the square root of, and then we have to the power of 5. Then we have a choice here. We can do 16 to the fifth, or we can do the square root of 16. And so most of us are going to choose to do 4 first, and then write 4 to the fifth, which is 1024. And so here, if we do the same problem here, and again, I'm not putting the plus or minus here because we're given the problem to start with. Let's really start solving. We can get the plus or minus. So 64 to the negative 2/3 power. The 3 is the root, but we have the negative exponent to deal with as well. So we're going to make it 1 over root 3 64 squared. So now what is the cube root of 64? That is 4, and then 4 squared is 16. So this is 1/16. Now let's go the other way with this. We can actually take this problem here, the cube root of 3 to the 4th. And so we can rewrite that as 3 to the power of, the exponent stays the exponent, the root is a denominator. So think about a tree. When you have a tree, the roots are on the bottom of or underground. And so the same thing on the exponents. The roots are going to be the bottom of the denominator. And so this would be exponent form of this radical value. So we want to solve this. We can actually go through and first divide both sides by 6. Mental math, 6 goes into 36 6 times. We have 1 left over, so that 7. So we have 1 left over, makes 15. 6 goes into 15 2 times with 3 left over, and then 30 would be 5 times, so 625. And then we need to do the fourth root to both sides. So we have x equals the fourth root of 625 is 5. And you can think about this. What does this mean? What is the fourth root of x to the fourth the same as? If we put that into exponent form, it's going to be x to the power of, the exponent is 4, the root is 4, which is x to the first power, 4 divided by 4. So you can see how those undoes each other, the opposite. And so this is how we get the x. But one last thing is, since we did the fourth root to both sides, we still need to include a positive and a negative. We keep forgetting that in class. We got to make sure whenever it's an even root to both sides, we have to include the plus or minus here. And so this problem is similar, where we need to do the root to both sides, but it's the opposite of the reciprocal of this exponent, which is going to be the cube root. So the cube root to both sides. So we have x plus 1 equals the cube root of 18. And then we have x plus 1 equals, now we don't have plus or minus here because it's an odd degree. We can look at 18. 18 is 3 times 3 times 2. There's nothing we can pull out of it, so that's it. And so all we need to do to simplify this is subtract 1 to both sides. So I'd write x equals negative 1 plus 3 root 18. And you don't have plus or minus for this one because it's a cube root. That's it for 6.1. For 6.2, we're just doing more, looking at all properties with rational exponents. So now all of the old rules we dealt with are fair game. So how the square root of 4 can be written as 4 to the 1/2. That's from 6.1. And then we can look at that as 2. Square root of 121 we should realize is just 11. Quick review. Cube root of 125 we should just know is 5. So that means we should know mental math. The fourth root of 256 is 4. So some of these we should start to get familiar with. Reviewing some of these, x to the 1/2 power is the same thing as the square root of x. X to the 1/3 power would be the cube root of x. 9 to the 1/2 is saying the same thing as the square root of 9, which is 3. 64 to the 1/3 is 4. It's the third cube root of 64. X to the 2/3, I could write that as the cube root of x squared. And squared doesn't matter if you put it underneath the radical or not. And then this one here, we can do the cube root of 8 squared, which is going to be 2 squared, or 4. And so let's do a quick review of some of the stuff on 6.1, just more examples. What we're going to do is, using some of our old examples, we're going to do it with exponent that are rational numbers or fractions. X to the m times x to the m times x to the n, that's x to the m plus n. So if m and n are fractions like they are here, it's going to be x to the 1/2 plus 1/2, which is 1, or just x. For this problem here, you need to add them. So again, to add 1/4 and 2/3, you need a common denominator. So it'll be 12. So it's like 3/12 plus 8/12. So then we get x to the 11/12. So it'll be the same thing as x to the 1/4 times x to the 2/3. It's 11. X to the -7/2. We've already kind of done this. We can write it as 1 over the square root of x to the 7th power. And so then we can keep going with some examples. This is now the power to a power, so we actually multiply those. So this will be x to the 1/4. And this one here, we multiply these as well. You do not need a common denominator to multiply, so this is going to be 3/30 or x to the 1/10, so it's really the 10th root. So you can see where fractions, you're going to be good at fractions, be useful. Some other examples, now we can start simplifying. This is just the square root. We should be pretty fast at this. I see this is 18 as 9 times 20. We can look at that. So this is 3√20. Or I can say this is going to be 3 times 2, or 6 times √5. So you can write it as that. For 2, we have the 4th root of 625. I know it's 4. Actually, 4th root of 625, I know is 5. And then the 4th root is z to the 12. Now we've not talked about this yet, but if I put that, the 4th root of z to the 12th, and I put that into exponent form, this is 5 times z to the power of, the exponent still 12, the root is the denominator, so 12 over 4 reduces to z to the 3rd. So you're really taking the exponent divided by the root, if that divides. And so the 6th root here, we can apply it to both the numerator and denominator. This is just going to be r, because it's 6 divided by 6, over x to the 3rd, 18 divided by 6. And so that's going to help us out tremendously just to divide those. Back to 3, we're doing the cube root of these. The cube root of 6, we don't know that. There's not a value for that, but we can break this up. So here, cube root of x to the 4th. We don't, 4 divided by 3 is not a whole number, but I can pull out an x here. Move that over actually. And leave the 6 here, and leave another x in here, because this right here, x to the 4th, is the same thing as x cubed times x, and the cube root of the x, I know that portion is just x, and the other x is going to stay underneath the root symbol. So the cube root of y to the 9th is going to be y, 9 divided by 3 is 3, and the cube root of z to the 14th, we can't do 14 divided by 3 to get a whole number, but I can do 12 divided by 3 is z to the 4th, and we had z squared left over. So that one right there is a little more complicated. So here would be the final answer. A little tough when you have all those exponents and roots. So here for 5, this is a power of 1/5, which means it's really the 5th root to all of these. And so if it helps you to write it as the 5th root of 32, you can write it like that, times m to the, now we're going to multiply 5 times 1/5 and get 1, and into the 30 times 1/5 is 6, and the 5th root of 32 is 2, so we end up with this. So we struggled with exponent rules in the past, but now we're combining them with fractions, with the radical notation, so it's going to be a little more complicated. And that's really the end of 6-2. Have a good night.